Good day everyone, my name is Dagum from the ECE 3C. In this video, I will show you the ECE 23 Performance Task number 9, which is the arithmetic coding. Here in this topic, I will show you how to encode the code given message into binary data. Then the binary data, we will decode again into its original message. Here we have the given information or message from my ID number, which is 2.2018-46438, where A is the end of file or the end of our transmission. Then we will get the probability of its code word. Here is the encoding. How to encode our code word here. The code word here, we should plot it in the probability graph. Here from 0, 1, 2, 3, 4, 6, 8-8. Since we have to get the probability graph of 2 first. The 2 here is in between 0.2 and 0.3. Expanding it will become the upper bound and the lower bound. And to get their step value, we need to get their difference first, then divide by 10, it will become 0.01. Next is the probability graph of 0. The 0 here is in between 0.21 and 0.2. Expanding it will become the upper bound and the lower bound. And we have this step value here, which is 0.001. Then we should get the probability graph of 1 using the probability graph of 0. Here, the 1 here is in between 0.202 and 0.201. Expanding it will become the upper bound and the lower bound. Then we have its step value here, 0.0001. Next is to get the probability graph of 8. The probability graph of 8 here is aligned between 0.218 and 0.217. Expanding it will become the upper bound and the lower bound in this graph. And we have the step value here is 0.0001. Next is to get the probability graph of 4. The probability graph of 4 is in between 0.2176 and 0.20174. Expanding it will become the upper bound and the lower bound, and its place value here is 0.00002. Then locate the probability graph of 6 using the probability graph of 4, and the 6 here is aligned between 0.21754 and 0.21752. Expanding it will become the upper bound and the lower bound of this graph. And we have the step value here, which is 0.000002. Then locate the expanding it, we need to get the probability graph of 3, which is 0. Between the aligned here 0.217528 and 0.217526. Expanding it will become the upper bound and the lower bound, and its step value here is 0.000002. Then using this graph, we will get the probability graph of dash. The dash here is aligned between 0.2017527 and 0.2017526. Then expanding it will become the upper bound of the lower bound. To get the here, to locate the A here is it is aligned in 0.2175278 between 0.2175278, and the letter A here is the code word A is our end of our file or end of our transmission. Then we have the upper bound here in the lower bound. To get the middle bound, we need to add the upper bound and the lower bound divided by 2, and that's the middle bound, which is 0.201752779. Convert middle bound to binary, we'll get the binary data or the encoded word. The middle bound here will become 0.0011001101100100110001 base 2, and that is the encoded word. To check, convert back to decimal. The decimal here will become 0.201752666265869140625 base 10. Here, in this encoded data, the average bits per symbols here is equals to 20 digits in the encoded words over the digits of middle bound. Then it will become the 2.22 bits per symbol. Here is the process of decoding. We have the received code and the decimal code. To decode here, we need to use the decimal value. Since we already have the plotted graph, we will use the decimal value to get the to decode into its original message. First, we have to locate the decimal value here. The decimal value here is in between 0.3 and 0.2. Then, the code word here is 2. Expanding it, will we will locate again the decimal value here. The decimal value here is in between 0.21 and 0.2, which is aligned to the code word of 0. Expanding it and locate again the decimal value. The decimal value here is in between 0.202 and 0.201, which is the code word here is 1. Expanding it, locate again the decimal value here. The decimal value here is in between 0.2018 and 0.2017, and the code word here is 8. Expanding it again, locate again the decimal value here. Decimal value here is in the range of 0.2176 and 0.20174. Since we located it, the code word here is 4. Then expanding it, locate again the decimal value. And it is located at between the range of 0.21754 and 0.21752. Then the code word here is 6. Expanding it again, locate again the decimal value, which is 0.2175. It is between 0.217528 and 0.217526, and the code word here is 3. Expanding it again in the graph, locate again the decimal value. Then the decimal value here is located at between 0.2175278 and 0.2017526. Locating it in the align of code word dash. Then expand it again, locate the decimal value here. Since the decimal value here is in the range between 0.2175278 and 0.2172778, and the aligned code word here is A. The A here is our end of file or end of our transmission. Lastly is the summary. The summary here is the arithmetic coding, which is the ECE, is a type of lossless data compression entropy encoding. In most cases, such as the ECE code, a string of characters is represented by a fixed number of bits per character. When a string is converted to arithmetic encoding, frequently occurring characters are stored with fewer bits, while less often occurring characters are stored with more bits, resulting in fewer bits being utilized. Overall, arithmetic coding differs from other types of entropy encoding, such as Huffman coding, in that it encodes the entire message into a single integer, an arbitrary precision fraction q, where 0.0q 1.0, rather than splitting the input into component symbols and replacing each with a code. It is according to Wikipedia. And that's all. Thank you.